Welcome back, Mindsetters. I hope you guys really didn't move off your seats. I am loving the answers and the interaction on the page. I'm glad to see that you guys are actually awake and present. It's very refreshing. Over to you.
Okay, well, welcome back, guys. I can see that you guys are listening very, very carefully. I saw that Southeast comment kind of really through a few of you. What I'm going to be doing now is I'm going to be showing you on the floor how to tell the difference between a resultant and the individual pieces which go into it. Some of you are asking what the difference between a resultant displacement and a displacement are. I'm going to be talking today mostly about the resultant displacement. Now, displacement usually is a resultant. Now, I'm going to show you what that means in a second. What I've done on the floor is I've actually drawn out two different ways of getting to the same place. So I've got a start here, which is down here by my feet. This is where I'm going to begin. Now, what I'm going to be doing is I'm going to be moving in two different directions, and that's exactly what I've done in the challenge question. So I'm starting here by the start, and we're going to be moving in one direction. Now I'm going to start with a solid line, and I'm going to go in a direction. I'm going to use this as an indication. Now, what I mean by a resultant is what is happening at the end of everything, once everything has been taken into account. So if I use the word resultant, it means everything together. So what I'm going to be doing is I'm going to be moving from my starting place, and we're going to be moving 1 meter towards the other side of the shot. So what we're going to be doing is we're going to be taking one step, and we're going to be landing up here. But what I'm going to do now is I'm going to add to the distance. I'm taking another path. Notice how I used the word distance. So I stepped 1 meter, but then I moved 1 meter in a certain direction. See how I've got an arrow down here on the floor? That means that I've moved with a vector quantity. So now it wasn't only distance, but by giving it direction, I made it into displacement. So what I'm going to do is I'm going to move another 2 meters in a certain direction, and we're going to see where we end up. So let's move our 2 meters in the direction towards you guys, and I see that I've landed up at the end. Now the question is, what is the resultant of what I've just done here? Well, I'm down here at the end, and what's happened is I've moved from my start over there, and I've actually moved down to the end. The question is, how did I get here? Well, I moved 1 meter, and then I moved 2 meters. So I've moved a total distance of 3 meters. But now here's the question. How do I get the displacement or the resultant displacement of what I've done? To do that, I've got to go right back over there, and I've got to go right back to the start. So let's do exactly that. So I've got my start here. What I'm going to do is I'm going to show you my displacement. An easier way to get to the end would have actually been to go straight down this dotted line towards the end, from the start to the end directly. And that is my displacement. The difference between distance and displacement is that I would have to travel 1 meter, then 2 meters. My resultant is going to be slightly shorter than the total distance, and that's generally always the case. The resultant is the immediate distance from start to end. Sometimes they call that as the crow flies. Now, if you want to go to the other side of a block, the easiest way, if you had wings, was to fly over it just like a crow. So when they say, as the crow flies, that means that I'm going directly somewhere. What I'm going to do is I'm going to go back to the board, and I'm going to show you how this works with our challenge question. A lot of you guys are really racking your brains, and you're really struggling. What I'm going to do is I'm going to go right back to the beginning of the show, and we're going to use our challenge question. So let's go back to it, and let's put you guys out of your misery, and let's figure out what goes on here. Well, some of you actually managed to figure out that I'd left out a unit. Remember, I told you guys that we'd left out something inside the 1, and that's very good. Most of you managed to figure out that I had to say 30 meters. Now what I'm going to do is I'm going to help you figure out what's going on in the challenge question. Some of you have got the right answer, and you've actually managed to figure out that I'm using a vector. That means that I've got to use an arrow for each one of these quantities. So let's make a little bit of space, and let's see how we can go 40 meters south, then 30 meters east. So what I'm going to do is I'm going to grab my handy arrow. Now, you guys don't have this tool at the home. So what I'm going to do is I'm going to do this very slowly, and I actually want you to do this with me. Now, the question is, how big should I make my arrow? Well, here's the answer. You've got to choose an arrow which reflects your vectors all the same. So what I recommend that you do when you're drawing vectors, and this is a very good lesson to learn, is to choose a scale. Now, a very good scale for something like this might be, so, well, if I'm going to choose a scale for this, well, I've got to represent 40 meters. Now, that's a very big piece of paper. I cannot stretch out over half a rugby field to work out a vector question. So how do I make that slightly smaller? Well, you can start off with something quite simple and say that, 1 centimeter is going to give me how many meters? Well, you can actually decide. So what I can say is that, I've got my 1 centimeter. Let's measure out, we can do 4 centimeters if you like. That means that 1 centimeter equals 10 meters. So now the question is, how do I represent these other vectors? Well, I've got 2 arrows, and these are a bit of a problem to represent. So now what I've got to do is I've just got to make a bit of a shopping list. I just want to make sure that everyone knows what we're doing. We're going 40 meters south. Then what we're doing is we're going to go east after that. We're going 30 meters east. Well, okay. So now we've got some information, and I've chosen some cardinal points. Well, the way to start these questions is to draw the cardinal points. So let's do exactly that. So I'm going to draw a set of cardinal points over there. There we go. And we're going to start out here. So now what I want you to do is to draw with me. Let's make sure that we've got enough space, and I want you to draw this exactly with me. So let's start out by saying we've got an arrow. Let's actually make that into a different color so that everyone can see. There we go. Whoops. We've actually made our background. Let's go back to there. Okay, so let's make a little bit of space over there. Let's get ourselves a blank page rather. Otherwise, nobody can see what I'm doing. Okay, so our vectors with arrows, let's start off with our cardinal points. And let's actually start to go south. Let's make it green so we can use our yellow arrows. That makes life nice and simple. Okay, so starting out with our cardinal points of north. Let's start using our arrows. The question is, how long did we choose our arrows to be? Well, if 1 centimeter gets me 10 meters, how many centimeters would get me 40 meters? Well, let's do this. 1 is to 10 as something is to 40 meters. Well, I hope that you can see. All that we have to do is we have to figure out how to use our ratios. So let me give you a little bit of a tip on working with scales. I want you to write them exactly like this. And this allows me to do something quite cool. So I want you to split your ratios into 4 pieces. Now, it depends on where you're starting from and where you're going to. So I'm starting with 40 meters, and I want to get into this question mark block. Now, most of you guys have been working with the triangles, where any time you go over this line, this horizontal line, that means to divide. Anytime I go sideways, that means to multiply. So I'm going to write that in green. So now when I go from 40 to 10, I'm going to divide. So I'll say 40 divided by 10. What does that get me? That gets me 4. Then I multiply across 4 times 1, and then equals at the other side. So I've actually gone around like this. So I divide, then I multiply, then it equals, and what I land up with here is 4 centimeters. Let's just make sure that's nice and neat. I'm making a bit of a scribbly mess over there. So what we've got to do, there we go, 4 centimeters. I'm going to go through this again in a short moment. Don't panic, we've got to do another one for our other unit, for our other quantity. So now, how do I represent 40 meters? I start off on my cardinal point right in the middle. So let's do that. There we go. So we started off with a 1. I've drawn a line, which I want you to draw this out with the ruler. Let's just make sure that's out the way. And that's 4 centimeters. When you've drawn a vector, it's always a good idea to mark it with the exact amount that it represents. And that is 40 meters. Now, on your page, that's just going to be 4 centimeters long. The question is, where do I go from there? I've started over there. I've ended up at the end there. And I've ended up 40 meters south. So I've gone south. The question is, now, do I start back from the beginning? No. I've traveled south. Now I can travel east. So let's do our ratio again. Let me show you how to do this ratio. Okay, so once again, I've got 1 centimeter to 10 meters. And we're going to draw our little cross over there. And we want to now make 30 meters. How do I make 30 meters into centimeters using our particular scale? Now, this scale is very, very easy. I'm sure that most of you have actually managed to figure this out without thinking too much. but I want you to practice this method. It's very useful for any ratio that you come across. You put your ratio at the top, and then you put your unknown next to your known. So I know that I've got 30 meters. So I divide by 10. I multiply by 1, and I land up with a different result. So that's divide. Then I multiply to go across. Then I say equals. So I say 30 divided by 10, multiply by 1, gets me 3 centimeters. Okay, so let's put in our last vector. I know that I've got a 3 centimeter line stretching out in that direction. Now, lots of you are saying, okay, well, that puts me southeast, and that is not true. What I'm showing you is that I've got 40 and 30. Now, if I draw in a resultant line, what I'm going to actually do is I'm going to connect this. A resultant displacement over here. Let's draw that in with a green pen. Okay, this displacement is what I'm after. Now, I think we're going to run a little bit short on time, but if you work this out using Pythagoras, what you'll find out is that your displacement over here from start to end is actually 50 meters. So I do this by Pythagoras, and that gets me 50 meters. Now, it's not southeast. This is not southeast. Southeast is around about over here. The question is, how do I get the true direction? Well, you can do this by measuring on your page if you're absolutely accurate. What you'll find is that you can measure around right from the beginning over there, and you're actually going to find out that the correct answer is actually B. So let's just go back to that and discuss what that bearing is. There it is, a bearing of 143. Here we go. That is our correct answer over here. So if you selected B and you explained yourself well, that might mean that you get a calculator. Doesn't mean for certain, but if you got there first, that's great. A bearing of 143 was the correct answer, and you had to actually measure that off your protractor. Now, just for reference sake, a bearing of 135 would be southeast. Please make sure that you get that right. I think that's around about all the time that I've got to explain vectors and scalars for today.
I think that was awesome, and I know that the learners really enjoyed it, Phil, because they said they enjoyed it. So thank you very much.
Sure.
And thank you, learners. You guys were absolutely amazing today. And remember, help each other on the page, even when we're not there. Just make sure that you explain everything fully. It was such an awesome show, and I hope to see you guys for physical science next week, Tuesday. Thank you again to Liberty. Liberty has been absolutely awesome. See the grade 11s next up for physical science. Bye, grade 10s.